and focal lengths.
I'm giving it a go here, guys. Hang on.
You ready to go?
No, just 1 second. I'm going to see if it goes. Okay, looks like we're going to go now. And I guess we're good. So you can go ahead, Paul. Cue the music.
So you want some tunes?
Give us some tunes.
All right, here you go.
All right, and good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Had to take a pause there for a minute and try to make sure that we had the connection on both Facebook and YouTube. We are now up live, I guess, as it appears to me anyway.
Yes.
Great, okay, good. So first of all, I'd like to welcome back our regular co-host, Royal Astronomical Society of Canada member, Mr. Paul Owen from the beautiful dark skies of Hampton, New Brunswick.
Yes.
Beautiful
Yes,
cloudy skies of Hampton, New Brunswick. And, and also Royal Astronomical Society of Canada member, Mr. Mike Powell from the PFO Observatory here in St. John. Mr. Mike,
Yay.
with Mr. Alien in the background there enjoying the binocular view.
Yes.
Yeah. Only he had a window.
Yeah. He's pointed in the wrong direction.
He is.
Okay. Unfortunately, this evening, our special guest that was going to join us this evening, Trudy Almon, is having a connection problem from the dark skies in Fairfield. I said that right.
You did say that right.
Yeah. Unfortunately, her connection isn't the very best tonight, so we did do a test run yesterday. Everything was fine. Maybe there's a lot of people on the internet down there tonight. Maybe everybody's down there watching our show tonight. Who knows?
All six of them.
Yeah, all six of them.
I think it's the people in St. Martin's that are giving her trouble. So
Yeah.
That's more likely it. Yeah. So anyway,
Not paying tax.
unfortunately, we can't have Trudy with us tonight, but she gives us her blessings and hopes that we can have her join us next week, possibly. We'll give it another shot. So, besides all that, then, I guess we're going to take a look at one of our newest segments this week, which is, what is that anyway? Oh, yeah. Where are they now?
No, we don't even know what it is.
What's our new segment? Our new segment's going to be called Where Are They Now? It's basically about space missions that are out there, look at past and present space missions, and that's going to alternate every second week with our What's New in Space talk that we normally do at the beginning of our talk. Also tonight, Mike's going to be offering us another one of his new segments, Binocular Targets of the Week. Hey, Mike.
Yep.
And Paul is going to offer us another interesting Rosanna's Fun Facts segment tonight. Hopefully, too, if we have time, we're going to spend some time looking at the free program Stellarium, specifically how to find your way around the night sky when you're trying to pinpoint something special. We talk about something being in the southwest sky, 60 degrees up, that kind of thing. We're going to try to narrow that down a little bit so that we can all kind of not have to spin our heads around looking for something. So we'll do a little bit of looking at that. And also, we're going to take a look at your wonderful photo submissions, of course, as well. And we'll take a look at all your questions about telescopes and stargazing and more. There's Trudy. Keep it up, and I won't do the shares. Hey, we did mention Fairfield. Easy now. So, yes, he's joining us this way anyway, for sure. So sit back and enjoy, folks. And remember, this is a family-friendly live broadcast. Easy for me to say. Stop it. You guys want to do this? Here, you can read the notes. I'll hold them up.
I'll wait for the DVD.
So I guess let's get started with what's our newest segment, Where Are They Now? So, Trudy, if you wanted to join us by phone, you're still able to use that same link I sent you. Just a little bit.
You know, you could use that topic on Trudy. Where is she now?
Where are they now? Yeah.
Oh, easy, guys. Easy now. Yeah. We got to be nice to Trudy. Okay, let's take a look at this. So I guess, first of all, we'll say hello to everybody out in YouTube land. Bruce, CDB, Trudy. Hi, Trudy. Paul Crowder. Welcome. Cloudy skies of the UK. Well, welcome, Paul. It's cloudy here for us as well. Bridget's on with us and Alan Legier. Evening, everybody, on YouTube. On Facebook, we've got Alan, we've got Lisa, Kathy, Eves, Susan Brown, Brad and Donna Kraft, and Nelson Hogan. Hey, there's a light bridge, and the colors are like all over the place. I see it every night, but we'll have to talk about that a little bit later. Nelson for sure. And Renat, Maggie, and Stefan, and Denise. Well, nice crowd here tonight. Jamie, Emma, Suzanne. Wow, awesome. Great, let's get started. I'll stop talking. Well, for a minute. Okay. I get so excited. Yeah. So glad it's legal now, huh?
I'm so excited. I just
Can't hide it. Okay, here we go. Enough of the foolishness. Well, not really, but okay. Let's see if I can get this thing to work. First of all, I got to go to this one. Bear with me, folks. I got to get a couple of windows open. And
That's hot here. I'm gonna open mine too.
yeah. So we got okay. Screen up. All good.
All good.
Awesome. Okay. This is our newest segment, Where Are They Now? It's called. And it's a discussion around current and past missions to explore the solar system and beyond. And our first segment tonight was going to be about the Lunar Reconnaissance Orbiter, or the LRO. And let's go down here to click the next link. There we go. So the LRO is actually a robotic mission that set out to map the moon's surface, and after its first year of exploration was extended with a unique set of science objectives. LRO observations have enabled numerous groundbreaking discoveries, creating a new picture of the moon as a dynamic and complex body. Now, the LRO and the Lunar Crater Observation and Sensing Satellite, or LCROSS, were launched together on an Atlas V rocket on June the 18th of 2009, and beginning a 4-day trip to the moon. Now, the LRO spent its first 3 years in a low polar orbit collecting detailed information about the moon and its environment. After its initial orbit, LRO transitioned to a stable elliptical orbit, passing low over the lunar south pole. And with a suite of 7 powerful instruments, LRO has collected a treasure trove of data, making it an invaluable contribution to our knowledge about the moon. The LRO currently transmits about 451 gigabytes of data per day. As of 2021, the LRO has enough fuel to continue operations for at least 7 more years. Awesome. Now, the NASA's Lunar Reconnaissance Orbiter spacecraft has far exceeded its planned mission duration, revealing that the moon holds surprises, ice deposits that could be used to support future lunar exploration, the coldest places in the solar system, in permanently shadowed regions at the lunar poles, and that it is an active world with shrinking, generating moonquakes, and changing in front of our eyes. The LRO has mapped the surface in exquisite detail, returning millions of images in starkly beautiful lunar landscape and paving the way for future missions under NASA's Artemis program. And all of those shots that you just saw there with that rotating moon were all taken by the LRO. Now, the LRO is equipped with the full suite of scientific equipment, and we're going to get into those. The Cosmic Ray Telescope for the effects of radiation, or CRATER. Everything with NASA is a shortened term, right? CRATER characterizes the lunar radiation environment, allowing scientists to determine potential impacts to astronauts and other life. It will also test models on the effects of radiation and measure radiation absorption by a type of plastic that is like human tissue. That's pretty cool. Diviner Lunar Radio, let's go back one. The Diviner Lunar Radiometer experiment identifies cold traps, areas cold enough to preserve ice for billions of years, and potential ice deposits as well as rough terrain, rock abundance, and other landing hazards. It also measures surface and subsurface temperatures from orbit. Now, the Lyman Alpha Mapping Project, or LAMP, searches for surface ice and frost in the polar regions and provides images of permanently shadowed regions illuminated only by starlight and the glow of interplanetary hydrogen emissions. The Lunar Exploration Neutron Detector, or LEND, creates high-resolution maps of hydrogen distribution and gathers information about the neutron component of the lunar radiation environment. The LEND data will be analyzed to search for evidence of water ice near the moon's surface. And the Lunar Orbiter Laser Altimeter, or LOLA, measures the slope of the potential landing sites and lunar roughness. LOLA generates a high-resolution 3D map of the moon. And then finally, the Lunar Reconnaissance Orbiter cameras. Those are two narrow-angle cameras on the Lunar Reconnaissance Orbiter that make high-resolution black and white images of the surface, capturing images of the poles with resolutions down to 1 meter. A third wide-angle camera will take color and ultraviolet images over the complete lunar surface at 100-meter resolution. Now, these images show polar lighting conditions, identify potential resources and hazards, and aid selection of safe landing sites. And the final one is the Mini-RF. The miniature radio frequency is an advanced radar that images the polar regions and searches for water ice. In addition, it is used to demonstrate the ability to communicate with Earth ground-based stations. All right, and from here we're going to take a little peek at LCROSS in a second here. LCROSS, just like on Earth, water will be a crucial resource on the moon, and transporting water and other goods from Earth to the moon surface is very expensive because water is so heavy. Finding natural resources such as water ice on the moon could help expedite lunar exploration. Now, the LCROSS mission searched for water using information learned from the Clementine and the Lunar Prospector missions. So we've got a little bit of a video here to show you. Next. And hopefully the sound's going to come through here okay. And we'll see. Let's hope.
On October 9th, 2009, a
Oh, let's try that again.
Centaur rocket impacted the moon, followed soon by NASA's LCROSS spacecraft. NASA's Lunar Reconnaissance Orbiter was there, both to help pick the location of the impact and to observe the resulting debris and vapor cloud. First, an impact site had to be selected. Data from LRO's LEND and Diviner instruments helped pick a good location. LEND to find a probable source of hydrogen, and Diviner to pick a cold, permanently shadowed region likely to contain certain volatiles. Once the impact occurred, these same instruments, along with LRO's LAMP instrument, observed the impact. LAMP revealed the presence of molecular hydrogen, carbon monoxide, and other materials. Diviner measured a noticeable change in thermal radiation coming from the site, and LEND reported the presence of hydrogen. All in all, these results both complement LCROSS findings and pave the way for future study of Earth's own satellite.
So LCROSS is basically a part of the mission that was used to try to find water on the moon. And we have found water in abundance, actually, in the hidden walls of some of the craters, mostly around the South Pole. Now, some of the most amazing science from the LRO has come from the result of the images captured by the 3 LRO cameras. From detailed images of some of the most prominent lunar craters to imaging the Apollo landing sites, these cameras have truly helped us develop a whole new understanding of our moon. There is a system of 3 cameras mounted on the Lunar Reconnaissance Orbiter that capture high-resolution black and white images and moderate resolution of multispectral images of the lunar surface. Now, LROC consists of 2 narrow-angle cameras that are designed to provide 0.5 meter per scale panchromatic images over a 5-kilometer swath, and a wide-angle camera that provides images at a scale of 100 meters per pixel in 7 color bands over a 60-kilometer swath. The sequencing compressor system supports data acquisition for both cameras. And here's another short video of the science being revealed with the wide-angle camera. So I guess one of the fascinating parts of that is that I didn't understand there were so many pits on the moon. Nope. Let me get ahead now here. Should have another picture. We should have another shot here. Yeah. Okay. Also, these cameras capture terabytes of images like these, including mosaics of the near side of the moon, the far side of the moon, the view from the North Pole, and another view from the South Pole. And we've even captured a beautiful close-up view of the interior of Tycho crater, which is this view here. And also a 100-meter boulder that rests at the top of the 2.5-kilometer mountain peak, right in here. You have no idea how that got there. I do think I missed one video. I'm going to go back a little bit, because I think I missed one. It was talking about the wide-angle camera. I think it might have been this one. Just bear with me. Yeah, this one, I think.
Lunar Reconnaissance Orbiter's wide-angle camera, or WAC, is creating a photographic atlas of the entire moon. By stitching together thousands of separate images, scientists can create a global catalog of the mountains, craters, and rills like those seen here near the landing site of Apollo 15. Color and contrast in WAC images give us clues about the chemical makeup of the lunar soil. The sharp border between the seas of Serenity and Tranquility, for example, is probably caused by differing amounts of titanium. Crater shapes reveal their ages. These three craters are like a time-lapse photo, from the youngest at the top, with sharp, well-defined features, to the oldest at the bottom, nearly erased by time. With the wide-angle images from LRO, we can improve our understanding of our nearest neighbor in the solar system.
Cool tunes. Okay, let's move ahead here to where we were. Of course, from here, there was lots of interest, of course, in whether the LRO cameras could actually image the Apollo landing sites. So in 2011, the LRO was instructed to dive, basically, to just 26 kilometers above the moon's surface to attempt to image those important sites. And here are the 6 sites where man walked on the moon, all imaged by the LRO. And here's a short video on the Apollo 12 landing site and what it was able to image. So the piece that we see there just off center is the piece that landed on the moon, the descent stage, I'll call it, the Intrepid descent stage. The ascent stage, of course, took off from that and went back up to join the capsule. And here we see lots of footprints leading out to the area where they set up their lunar experiments. One of the main parts of Apollo 12 was really to try to land as close as they could to Surveyor 3 craft. And they were able to do that. We'll see that in a second. So these are just footprints leading down to Surveyor 3, where they recovered some data and brought that back to Earth. More footprints leading around the area to a nice big crater called Bench Crater. And they're back up to home base again. So this is the type of data that LRO has been able to capture. And all of that information that we're looking at, all of that data that we see, of course, is footprints and other materials that are left on the moon's surface that will be there for billions of years from now, because there's no real atmosphere on the moon. So there's nothing for them to be eliminated. The only thing that will wipe those out is the micrometeorites, the 100 tons of micrometeorites that bombard the moon's surface every day. Eventually they'll fill in those footprints. But imagine placing your foot on something and it's staying there, your footprint staying there for over 1 billion years. And the LRO just keeps sending back huge amounts of data every day. So I would have to believe that this has probably been one of the most successful science missions to the moon to date, and hoping it does continue for a lot longer. And there's much more to be seen, of course. I've just scratched the surface, and if you'd like to find out more, you can go to lunar.gsfc.nasa.gov. And that's my presentation on the Lunar Reconnaissance Orbiter. Our
Nice.
first Where Are They Now segment. There.
So where is it now?
Where is it now? It's orbiting the moon. as it should be. Okay, we're back. There.
Well, that's really interesting what goes on with that. It's amazing how much we don't realize what goes on with those crafts. We assume they're just up there to do one thing, and they don't do a whole lot when they're there, but they're busy.
The thing is, the missions that NASA have been putting out, NASA, ESA, I talk about them as well, European Space Agency, but they've been sending out missions like this, and like that one was only supposed to last a year and a half, or 2 years, I guess, but now it's been its 11th year. And they go on and on and on. Like they just seem to, they get their money's worth well past their point.
But everything they send up there, it just seems to last longer in space.
Yeah, it's
Look at the Hubble telescope.
Yeah,
They're not built by car companies.
Yeah.
Well, they have double and triple redundancies. I know on a lot of the equipment, but it's just been studied to death. And every mission that they go up, they learn something new, and they incorporate that into the next mission. Even look at our Voyager spacecrafts, which I hope to talk about in a few weeks' time. I mean, they're 45 years now out there, way past the solar system, and they're still talking to them every day. So that's a really interesting. But they're getting very good at space exploration, at least with robotic space exploration. We're getting closer to the human part, but yeah. Anyway, okay, so that was my talk about that. So that's our first topic on Where Are They Now, and next week we'll go back to the What's New in Space one, and then we'll flip those out every second week or so. Give me time to make a new one.
Perfect.
Okay, let's go from there right to, how about Mike? We'll go ahead with your binocular target of the week next, maybe.
Oh, okay. Usually it's the last segment of the night.
Well, we're going to move it up. Consider yourself moved up.
Yes.
Start from first slide. And I have to present. Window. This one. So which one do you see? Just the Bino Bud?
Bino Bud, yes, sir.
You don't see the second. Good.
We see the Heidi's shot there. This is next.
Oh, you
slide.
do?
Yeah.
Okay, that's not the one I want.
Just
then.
switch your presenter view.
Let's try this one more time. See, it confused me.
I thought you were prepared. Well, you said an hour ago. You said about an hour ago. Okay, I'm ready to go on the show.
I am.
There you go.
We just got the one this time?
We got the one this time. Yes, sir.
Excellent. Now that you see the second screen.
we're gonna pin that one up. There we go.
Yeah, binocular target of the week brought to you by Bino Bud. That's the name I come up with for him.
Awesome.
Everybody was saying we have a name for him. And this target is called the Hyades, or the Nymphs of Rain. So the Hyades, also known as Caldwell 41 or Colander 50, is the nearest open cluster to us and one of the best studied star clusters. Located 153 light years away from the sun, it consists of a roughly spherical group of hundreds of stars sharing the same age, place of origin, chemical characteristics, and motion through space. From the perspective of observers on Earth, the Hyades cluster appears to be in the constellation Taurus, where its brightest stars form a V, along with the still brighter Aldebaran. In Greek mythology, the Hyades were 5 daughters of Atlas and half-sisters to Pleiades. After the death of their brother Hyas, the weeping sisters were transformed into a cluster of stars that was afterwards associated with rain. So, if you look up, there's the Hyades. You just look inside the circle. That's the cluster. So, you're actually looking for a V first, but there's a little bit more outside of that V, but the V is definitely distinguishable. Where to find it in the sky, if you were to go outside right now at 8:30 and it wasn't cloudy, at 260 degrees, which would be southwest, west-southwest, sorry, at 260, I believe. And look up, you will see probably the Pleiades first, and then come down from that, and you will see the Hyades cluster, or with Taurus, you look down, it's the center of the V, where Aldebaran is, the eye of the bull. Very, very easy to spot in the sky. This is kind of what you're going to be, whoops, go back one. This is what you're going to be looking at. The V is what you pick up the most, and then the stars around the V. And that's a beautiful color shot that someone took, and I should have found out and put his name on it, because that's a gorgeous shot. But this is what you'll see when you look through a pair of 10 by 50 binoculars. This is roughly what you're going to see. Aldebaran will stand right out. You'll still see the V pattern in there, and then you'll see lots of stars around it. So it's a very easy object to find. Just to give you an idea, again, here's a shot with the full moon in there, so you can see how big this cluster of stars actually is. The full moon doesn't even make up a tenth of it. So if you were looking through a telescope, you're probably looking at a spot that's just slightly larger than the full moon. When you're looking through binoculars, you're going to see the whole cluster, where you wouldn't probably catch the whole cluster in a scope. You catch some of it, but not all of it. It is huge. And that is Bino Target of the Week.
Awesome.
That's awesome. And it's actually placed so well this time of year.
It is.
It is. It's perfect.
I mean, all you got to do is go outside, look south. You're going to see Orion. Then you're going to see Hades and that little thing. It's the most dominant thing in the sky.
Okay, yeah. Can't miss it.
Awesome. Thanks,
Yeah.
Mike. Great stuff. I got a question here for Nell. Oh, first of all, we're going to say hello to Vivian Hogan out there. Good evening, Vivian.
Oh,
Hey.
hey.
And we're also going to answer Nelson's question. Nelson was asking, he says around 10 or 11 o'clock at night in the southwest part of the sky, he sees a very bright light every evening. So I'm going to say that it's probably the star Sirius. Right around that time of night. It does seem to set right around 10 or 11 now with Orion. So if you have the Orion, I'm going to get you to Nelson. Maybe you can check and see if Orion the Hunter is in that part of the sky at the same time. And just to the left of Orion, or east of Orion, you would see this really bright star. That's Sirius. That's the brightest star in our sky. And that star is mistaken a lot for this same. I've had this same question probably 5 times in the last 2 weeks. People have said there's a really bright light off in that, and it's all different colors of the rainbow. And that's simply because Sirius is so bright that it's piercing through our atmosphere, especially where it's down low, close to the horizon in the southwest. Our atmosphere is a lot thicker down there. So that white light that comes back through from Sirius through our atmosphere gets scattered up into different wavelengths. And we can see that in a twinkling kind of a fashion. And sometimes it's different colors as well. So if it is that object that you're seeing, if it's Orion that you're seeing that has almost set, and just to the left of Orion you see this really bright star, that's what you're looking at, Nelson. So hopefully that answers your question. Okay, so from there, let's go to how about Rosanna's fun fact? Are we ready for that, Paul?
No, well, actually, we'll save that for a little later. I'll do the little sky tour. Actually,
Okay.
While
All right.
we're still in learning mode.
Yep, sounds good.
Yeah, we'll find out if I was close with the southwest.
Yeah.
260.
You were actually, Mike, you were bang on.
Was it? Okay.
In fact, yeah, you were bang on.
Oh, awesome.
Yeah, I'm looking at Stellarium now. I'll show that to you, but
Good guess.
no guess. You nailed it.
And one other thing Nelson mentioned, talking about how come there are no pictures on the dark side of the moon. There are pictures from the dark side of the moon, Nelson. It's just that, and there's no really dark side. There's a near side and a far side, because the sun, the moon always gets the same amount of sunlight throughout the month, because the moon spins around us, of course. But it's always has the same side facing us, so that's the near side that we see. There are lots of pictures on the dark side, but we can only get pictures from the dark side of the moon, or the far side of the moon, I'll call it again, when spacecraft started to orbit the moon. So when Apollo 8 started to go around the moon, or when we had our earlier missions around the moon, that was the first time we actually had pictures from the far side of the moon, except for this LRO spacecraft that is now orbiting the moon every day. So there, okay. Now, Paul.
You must be a Pink Floyd fan.
Oh, yeah. I always call it the dark side of the moon. Who isn't, right?
That's right. I know.
Yeah.
I am. Yeah. Okay, I'm going to share my screen.
Okay.
And then, or actually, before I share my screen, I'm just gonna, can you pin me anyway?
Sure. And anybody, yep. Anybody else who has questions along the way, Paul, I see you've got a question here too on YouTube. We're going to answer all these as we move our way through past Paul's, what Paul does his present. Okay.
Yeah.
You're pinned, Paul.
Okay. So, so basically, what I'm going to talk about tonight, and what we talked about, is a lot of the times we talk about all these wonderful things that we see up in the night sky, but not realizing that a lot of people that are watching, like us, when we first started out, didn't really know where all this stuff was. And in fact, so much so that there's probably still a lot of people out there that if you said point north, point south, point east, point west, they may not be able to do that unless they have some orientation or reason to have done that sometime throughout their lifetime. So, but with astronomy, and especially with the night sky, coordinates are everything. And if you don't have the exact coordinates, and knowing at least what direction or how we can kind of break our sky into pi portions, which is what I call it, and know, which way to look. So if somebody says, oh, look to the east about 25 degrees, and you're going to see this, or look to the southeast or whatever, and then you're thinking to yourself, where's that? I'm not even sure where that is. So what we're going to do is we're going to take this software called Stellarium, which is a planetary software, and rather than try to go through Stellarium and go this big long course and all this stuff that you probably forget half of by the time you got to the end, just maybe once a week or once every other week, we're just going to take a little piece of it and then show you how to use it effectively. Because first of all, Stellarium is a free download. You can download it on your phone. You can download it on your laptop, on anything at all. And once you've got to download it and understand it a little bit, you can take it with you or sit at home at nighttime if you got a couple hours and you want to plan a weekend, and you can do all those kind of cool things. And it's probably the most widely used planetarium software that's out there, and it's free. It's always updated, and it does so much. It's so powerful that we decided that that's the one that we want to kind of show you with. And a lot of the RASC programs that are going on across the country now, something similar to ours, they're all using Stellarium simply because it is probably the most comprehensive and easiest software in that format to follow. So anyway, so I'm going to show you tonight just how to use it and how to kind of orient to where you are. So if you observe, say, from your backyard or from an area nice and close to your house, I just want to show you a couple of ways that you can say, okay, where's the north? Like if I don't even know where the North Pole is, or I don't know what Polaris is, let's find that first, and then from there we're going to kind of show you, how to get around the sky. So having said that, I'm going to present my screen, and that should pop up here in a second. Okay, are we up, guys?
Okay, so I have to unpin you first of all, Paul.
Yep.
And I got so now I'm going to pin your presentation's pinned.
Hey, there's Heidi.
Yeah, right where we're talking about.
Right where you said it was.
Right where you said it was, Mike. I'm gonna pull this back a bit, and this is actually the night sky, and this is Stellarium, and this is a planetary software. So Mike was talking about southwest, west southwest, and so if you're looking at the southern sky, when you're looking at the software, it'll have the little letters on the bottom which indicate where you're looking. So this here would be due south, this would be southwest, and then this would be west. So right here will be west southwest, which is exactly where Mike's binocular target was, right there. And that's Taurus, and that's Aldebaran, and that is the Hyades, right there. And he was also talking about the Pleiades, which is right here. And if you see those two things, but you're not quite sure what you're looking at, just take a look over here, and you're going to see Orion. Looks like a great big hourglass, and he's got the 3 stars in his belt and all that stuff. So, so that's kind of what you're looking at in the sky if you're looking at it from the ground. It'll kind of look a lot like that. So let's get into the Stellarium program. So first of all, in order to be able to look at all this information that you see on the screen and figure out where all this stuff is, the first thing you're going to need to do is you're going to need to set up the software. So how you set it up is really quite easy. You basically just go to Stellarium, Stellariam, and just hit Google it. It'll come up. It'll say download, and just simply download it. Once it's done downloading on your computer, you're just going to have to do a couple of things. The first thing you're going to have to do here is you're going to do your basic setup, which is going to be this one right here. So this window right here is telling you, it shows you the map of the world. And as you can see, there's that little red arrow right there. And that's basically telling us that, because I've already got mine set up, where we are. So the important stuff to put in here, because if you don't put this information in the beginning, Stellarium won't know where you are. And it's going to pick a random spot. You could be somewhere in Boston or somewhere over in Peru. It doesn't know. So you have to set this up. So basically, there's what they call a reset location list. So you can just simply scroll up and down through here and try to find where you are, or you can simply name the city, type it in. I typed in Moncton just simply because it was one of the cities that was in the actual drop-down list, so I put that in there. And then you put in get location from GPS, or you can use current location or get location from the network, which is your computer network. Once you've got that information, it'll download your coordinates as to where you are on Earth. And right here close enough to Moncton and St. John, it's not a big deal in terms of how far the distance is. So that's basically the coordinates where I'm at. And it tells me the time zone that we're in, which is -03. Once you've got that set up, then you're pretty much home, except for you're going to close this window. Then you're going to go back over here. When you tap the side, these icons will pop up. And then what you want to do is you want to go into your sky and viewing options window. And you're just going to click on that. And then you've got a whole bunch of things up here on the top, all of these icons. Tonight, we're just going to focus on a couple of them because again, I just want to kind of get you used to using this as to where do I find things and what's my orientation and how do I get there. And I don't really want to cloud up too many lines on this thing. So the first thing we do is we go to Sky. And on Sky, you're going to see a number of different things that you can check off or not. And these ones are default. So I would just leave the default ones on the Sky settings. Basically, it gives you the Milky Way brightness and saturation. It gives you the zodiacal light brightness. So basically, if you're going to look at some of these features, there's a certain brightness that'll come to it. The stars, the absolute scale, like all of these things are set up for default because it's the most common brightness levels that you're going to want to use for the sky. If you crank up that magnitude level too high, 13, 14, which is what some of the more powerful telescopes will get you into. The trouble with that is when you go to look at a star, you're going to see so many stars, it'll blow your mind. So you want to keep it back to about where your eye naturally sees. Our eye naturally sees between, if we're very young, between 6 and magnitude 6 or 7. Binoculars, you can see right up to about a magnitude 9. So if you want to go ahead and do a magnitude 9 just to see what binocular views would look like, you can do that. But if you want to start off just standing on the ground and just pretending you're outside and going in circles and looking at what's in the sky, you're better off to leave it at the human eye magnitude sensitivity, which is about 6.5. We move over to the next window, which is the solar system objects. So here you can kind of check off some of the things that you want as far as solar system things turning up on the planetarium software. Again, these are defaults, and I would just run with the defaults for the time being. And basically, if you want, you can show orbits for planets. You can show planetary nomenclature. In other words, the names of the planets and all that kind of stuff. There's a lot of stuff you can add in as you're going down the line. But if you just start out with this one, at default, you'll be good. Move over to our DSOs, which is our deep sky objects. And the default on this one works quite well. And what they have checked off here is in display objects from catalogs is M, which is the Messier Catalog. So they have 3 of them, which are the 3 most widely used catalogs. The Messier Catalog, the NGC Catalog, and the IC Catalog. And what I mean by catalog, these are all deep sky objects that have been basically document it, going way back to Charles Messier and even further than him, actually. And but he was one of the first ones to start to do all these. What's that in the sky? I better document that, put it on a sky map, and now we know what this is. And we've been using his catalogs forever. He's got 110 objects on it. The IC catalog and the NGC catalog. The NGC catalog is full of galaxies, and this time of year, actually, NGC catalog is a great catalog to get into, and of course the IC catalog. So those are the defaults that are set there, and those catalogs would be the ones that I'd recommend that you use. And then you go over to markings. This is the one that I'm going to kind of show you how to get oriented with Stellarium and where you are in your part of the world with. And on the markings one is there's a line called the meridian. I want to check that off. And there's also a line called the ecliptic, and I want to check that off. And I'm going to show you why here in a second. So I'm going to turn that off. So basically, just a quick review. We've got it all set up. We've got our coordinates in there. We know where we are now. We're ready to go that way. We've gone through and we've basically clicked off some of the things that we want to start with. And we got our star magnitude set to where it's going to be good for us. So now, excuse me, I'm just going to turn off the date and time just for a moment so I can see the screen better. So anytime that you're in Stellarium and you've got it all set up, if you go down to the bottom, you're going to notice that there is a grid and it's got all kinds of icons on it. I'm going to turn off the first two, and I want you to see what's happening when you look up at this display. You're kind of seeing what you would see. Let me just see if I can get. There we go. So I want to take this off. There we go. So that's kind of like what the night sky would look like. So if you're in your backyard, obviously when you go in your backyard, there's no names and labels in the sky. It's just a whole bunch of white dots and whatnot. So we got to figure out how do we make sense of those white dots and where are we? So the first thing that I'm going to recommend that you do is learn to find out where the North Star is. And the North Star being Polaris, which is right up here. Now, when you look at that at nighttime, you're going to see these brighter stars, these three right here, plus this bowl shape, and that's called the Little Dipper. And the Little Dipper, I'm going to now give you the line, so I'm just going to push this button. And this is the lines that kind of glue this all together. And so this is the Little Dipper. So if you're standing and you're facing due north, I'm just going to shrink it, go back a bit, and you're looking exactly north, you're going to see Polaris right there, and that's about 46 degrees. How do I know that? Well, if I go over here, I have two grids I can use. If I press on the first grid, it's going to give me a whole bunch of these lines and these little blocks. And in these little blocks, each of these blocks is 10 degrees. So if my horizon, which is right where that land meets the sky, that's the horizon. The very first block from the horizon to the top is 10 degrees. So if I go up another block, it's 20 degrees. If I go up another block, it's 30 degrees. So basically, that's how you find how high up things are. So when we look up here at the North Star, let's check here now. Let me just do something. Put the right grid on my hill. There we go. So there's 10 degrees, 20 degrees, 30 degrees, 40 degrees. And it's right written on the side. I don't know if you can see that clearly, but there's the number 10 over here in this corner. Right above it, the number 20. Right above it, the number 30. And that just indicates the degrees from the horizon going up. Now, if you look at the top, you're going to see lines going this way. This one says 10, that one says 20, that one says 30, 40, 50. And basically, they keep going around 80, 90, 100. If I go in a complete circle, what's a complete circle? 360 degrees. So I'm coming right back to 350, and I'm right back to where I started from, 360 degrees. So I've just turned a complete circle. So that's basically what, when you look at these numbers here, that just indicates how far going west to east you are. And then the numbers on the side are going how far from the horizon up you are. So now let's figure out what's east and what's west. So I'm standing there, and I think I'm looking north. I found the Little Dipper, and I found the North Star. So somebody says to me, I should look southwest. Which way do I turn? Well, it's like this. I'm now going to include, which I think I already put up there. Let me see if I did or if I didn't. Yes, I did. Good. I've got the ecliptic line, and this is one of the things I wanted to demonstrate for you. So what the ecliptic is that orange line, and this is an imaginary line that the planets and the sun and the moon follow. So if you get up in the morning, the sky, the sun as we know it, rises in the east and it sets in the west. So here now, does the same thing the moon does. But now I'm looking north. So if I look north, if I'm facing north rather, then the east is going to be on my right-hand side. The west is going to be on my left-hand side. And if I've got my arms out and I do a 360-degree turn, I am now facing south. And I'm going to show you here. So I'm just going to spin all the way around. Now I'm facing south. But now look, the west is now on my right-hand side and the east is on my left-hand side. And why is that? Because again, we did 360 and we're facing the opposite direction. So, so how do I know if I'm facing south or north? Well, the first thing you need to do is, let's go back to where we started, is learn a little bit about the North Star, because the North Star is the only star, in our perspective from the northern hemisphere, it's the only star that really, it moves, but not enough that we perceive movement. And so we use that as an anchor point. And years ago, when they used to navigate in the water, they used to use that as a north. They knew that looking at that star every night, that they were going to be heading north. Or if they were going to the east, they know they'd find a North Star and they start heading towards the right-hand side. If they had to go west, they find that star and start heading toward the left-hand side. Now, they also knew that if they saw that star and did 360 degree, then they knew they were facing south, and they'd have to go southwest, then they would be using their right-hand side to go west, and they would be using the left-hand side to go east. So to make it even simpler to understand that line that you see right here, that green line that we talked about, the meridian, it goes directly from the south right up to the sky and right to the north. If I was able to take and, let's get back out here. There we go. If I was able to take and draw a line in the sand, I'm standing in the center of this bowl. Just consider this dome a bowl. I'm going to look up, straight up. I'm looking directly straight up. I got my neck cranked right back and I'm looking straight up. And right there is the North Pole. That would be as far north as we can see. That is 90 degrees. So if I go from the horizon, from the south horizon, 90 degrees up, I'm going to hit the top. And then I'm starting now to go back north and vice versa. So if I'm standing north looking at Polaris, if I look straight up in the sky and I turn around and I start looking downwards, I'm going from 90 degrees down all the way back down to 0, which is that point on the horizon. So I just want to show in time now about this ecliptic, because understanding the ecliptic will be your friend. So if I take the time thingy, there we go. So here's the moon. Now we know, as we talked earlier, it rises in the east and it sets in the west. Let's watch it do it hour by hour. So let's go, there's 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. It's almost at the meridian. When it gets to the meridian is going to be the highest point in the sky that moon is going to be before it starts to make its descent back into the western hemisphere, or western horizon. So let's go another hour. So now you can see it's starting to drop and it's heading west. Let's go another hour. So keep an eye on those. Remember we talked about those square boxes being 10 degrees each? Well, this is where it is here. If I go another hour, see how it's starting to decline? And it'll go right down until it sets in the west. And guess what's going to happen on the opposite side of the sky? The sun starts to come up in the east, and it'll rise in the sky. As the day goes on, it'll cross that meridian, and it's going to set in the west. And as it sets in the west, guess what happens? This time of year, the moon comes up again. So you can see what's happening here is everything rises in the east and sets in the west. So if you can get your Stellarium program going, get it set up so that you have your correct orientation, go outside and at nighttime find the Little Dipper, and you know that that very star on the very end of the Little Dipper is called Polaris, and it's very, very, very close to the North Pole. Very close enough that again, that's our point we want to find. Once you find that, you know you're now facing north. If I look to my right, that's the east. That's where the sun is going to come up. If I look to my left, that is the west, and that's where the sun is going to set. And then if I turn around completely, those two things will be opposite, but I know then I'm facing south. So if Mike was to say, I want to go and look at southwest, I'm going to say, okay, I'm going to go outside. I'm going to find Polaris. Now I know I'm facing due north. Now I'm going to turn around 180 degrees. Now I'm facing due south. Now, if I'm facing due south, I know that the west is to my right. So I'm just going to look about halfway between the south and the west, and that's going to give me my southwest. West southwest area, and that's how I would find that particular binocular target. And as you can see right about now, if I hit the now time, just a sec here. Okay, there is actual real time right there. So Mike is still bang on. So that's actually hitting into the west and is starting to set in the western sky. So if I'm going out just now and I want to start observing things, I'm going to go out and I'm going to start looking around the eastern sky because everything's rising in the east. And if you want to start, say, where the moon is and you want to follow it all night, then basically just watch it hour by hour. And there's all kinds of goodies that are following it all night long. Your best views are always going to be, say, between the southeast and the southwest, because that's going to be the highest point of the target that you're looking at. And it's going to be the furthest away from that lower atmosphere where things can actually distort. So that is about as much as I want to cover with this for now. Hopefully, it's a good starting point for everybody. And if you want us to continue on with this and just kind of figure out how do you find things and so on, we've now talked about orientation and kind of setting it up a little bit. We just kind of got our feet wet in it. It's a program, again, it's called Stellarium. It's right up here in the corner. Just look for that little emblem of the little moon in the sky that you see there, and you can download it. It's a free download. Play around with it. It's easy to use. And again, we can't say enough about it. So hopefully that will get you started.
Well done.
There.
Awesome, Paul.
Well done.
Good stuff. Thanks, buddy.
Yeah.
A great start. And Stellarium is an awesome program, free to download. It's one of the most powerful free programs you're ever going to find anywhere. And it's perfectly suited for what we do. I use it all the time when I'm going out to plan for observing sessions. I find it's much better than even holding the phone up and taking a look. But because this way you can kind of plan. And you might notice a lot of my posts on my Facebook page too have clips from Stellarium. I'll talk about something going to be in the sky, and I'll always use Stellarium as a capture to help people out a bit. Thanks, Paul. Appreciate that. Okay, we're at about 8:57 right now, so we're gonna go quickly through photos. Yeah, we gotta get some photos here because some people are tuned in to catch their picture. All right, so let's see if I can get them up. Yep. All right, present now. Entire screen. And I got some fantastic photos come in this week. All kinds of photos, actually really good. So really happy to see that, as we always are. So let me see if I can get the first photo up here. Okay, that should present okay, I think. All right, these first ones came from Dave McCashin. Dave is a St. John Astronomy Club member. Who, we do miss being around Dave. We know Dave's busy on Sunday nights, but he has tuned in once in a while. But he's a great comet catcher.
Yes.
Dave loves doing that. So he says, "Hi, Chris. I've had some luck capturing some comets so far this year. Here are some of them. They're very faint." And he says, "Great show. Thank you very much." So he's got one here, Comet 141P Machholz, facing southwest, January 30th, 2021, at 7:58. Prince of Wales taken from Prince of Wales, Canada. So this is the comet here. Now I know you're going to say, "Oh, that's a blotch." You know, really, these comets are magnitude 8 to 12 or so, so they're very dim, and you really do have to take a fairly high definition or high, what I'm trying to say, high ISO capture to reveal some of these. But they are there, and if you go to Heavens Above website, and you click on comets, you're going to see there's probably about 20 up in the air at any one time above our heads. So here's another one that he's captured, Comet C2020 R4 Atlas. This was one that, I'm not sure if this is the one that's going to be coming around Christmas too. March 21st at 5:57 in the morning. Ooh, he's out up early in that one. Again, from Prince of Wales, very nice dark skies down in his area. He's got this one here, there it is right there in the center, Comet C2021 A4 Neowise at 2047 hours on March the 7th.
Those are great captures. Those are magnitude 14s.
14s, wow, yeah, see, so these are just taken with, I believe he's just taking these with a camera.
Probably on a C8.
Oh, a C8, on a C8, okay. So still a 14, that's still pretty dim.
Oh, yeah.
Yep. So there he's got one at D1 Swan, March the 7th, 2021. Dave, again, is an excellent capture of comets. He's been into this for quite a while now. And if I can go back one, I'm going to try this here just quickly, if we can get to it. Bear with me for a second. I think this will pop over here. Going to pop over. Yes, it is. Okay. So this is what Dave does as well. Dave does excellent observing reports. So here's one example. Sunday, March the 21st, a comet, Messier, and 2 planets rising. He's on blogspot.com. There's his address. Prince of Wales, New Brunswick. Date of time, 4:30 to 6:52. He even says the weather. You even seen in here saying just a few mosquitoes tonight. He comments. He comments on everything. Like, he's very detailed on his observing reports. Yeah. And there's his equipment that he used, Canon T3 attached to an 80 EDP APO at prime focus. And there's his shot. So he gives all kinds of detail on what he did. As soon as I arrived, attempted to image the summer triangle. So it gets right into all of his explanation, like very descriptive. We want to get Dave on the show here sometime and talk about these excellent blogs that he leaves. So you can find him at blogspot.com, Dave McCashin, 123429, I believe his number is. Anyway, all kinds of detail in here on all of the other posts that he's done.
You can read his blogs, and you'll hear the frogs chirping, and you'll hear
he tells a definite descriptive story. Like, that's just amazing.
Unbelievable.
Yeah. Captures every moment. So
that's the two things. I wish I could draw like Emil, and I wish I could write like Dave.
Yeah, absolutely.
Photograph like Paul.
Yeah, there you go. If you could do that, you'd be all set. But yeah, Dave gives a very descriptive portion of his observing session, so you can almost, it's almost like you're right there with him when he does it.
Yeah.
And that's a really good key when you're doing good observing reports. You can go back and review them later on and see how far you progressed as well. So this one's coming from Mike Thorne. Mike says, I've only been into astronomy for a year now and have not been able to take or talk with anyone. Thankfully, I just discovered your internet show. That's awesome, Mike. Thank you so much. Here are a couple of pictures, one of the moon and the other is of the ISS taken with my cell phone. Not quite the quality of Mike and Paul, he says, but don't you worry, Mike, you're going to get right along there. There's his ISS shot.
Oh, there's the ISS, yeah. Nice.
Awesome.
Yeah.
Keep at it.
He's not very good at it, but if you were to stand and watch the ISS go over, that's pretty much bang on what you see.
Absolutely. Yeah, absolutely.
Except moving, of course, but yeah.
Keep at it, Mike. You're going to get there.
Awesome.
Kathy Adams sent this one in. Kathy says, I really enjoy your Sunday night shows as well as the live updates throughout the week. I got out Monday night with my new scope about 9 p.m. and caught a picture of the moon with my 6 SE and a Sony A6500. I got my scope just before the crappy weather hit and haven't been able to get out much till now. There you go. Well, you're the blame. Okay. That's the astronomer's curse, Kathy. No worries. Yep.
A nice color image too, hey?
Awesome. Yeah. Enjoy the week and hopefully return to nice weather, she says. And then she sent me a second one later on saying, oh, sorry for 2 pictures this week, but this is just so much fun, she says. I actually
That's
tried
amazing.
stacking with this picture, but only half a dozen courtesy of our friendly neighborhood skunk.
Well
You
done,
gotta,
though.
yep, you got to get him to the telescope. Get him to the eyepiece. He'll enjoy that. Although it
Yeah.
did take, she says, it did take me 3 nights to realize I had my moon filter on and blocked out light from everything else I was trying to find. She says, there you go, next clear night. So awesome, nice job.
Yeah, beautiful.
We're going to keep going along here because we've got a lot to cover. I've got David Smart here with a nice pic from March the 23rd of the moon. Zoomed
Beautiful.
Well done, Dave.
What Mars is that, Chris?
in. Let's have another look there. That is the Sea of Tranquility right there in the middle.
Okay.
And there's a Sea of Crises down here in the corner, the same size as New Brunswick. Never heard me say that? Probably about
Oh,
10,000 times. All right, and we got another one here from March the 24th. Nice capture, nice done.
Nice
Very
picture.
well done.
Yeah.
And they sent us one of M42 as well.
Oh,
Yeah.
Now,
Awesome,
how many
David.
of us have taken that image, right?
Yeah,
You know, it's one of the first targets you take when you start taking astrophotography, and man, I remember the first time I shot that, it looked just like that, and I was so friggin' excited.
The
absolutely.
colors are going, yeah.
Awesome, David. That's awesome.
Yeah.
That's awesome. I love it.
Good stuff, good stuff. Get this one from Deanna King, her moonshot. Awesome, Deanna. Well done. Lots of
Of
moonshots.
course.
Getting lots of moonshots lately. That's awesome.
Yeah. Well, the moon's placed so well right now.
Yeah,
It never gets old either.
yeah, it doesn't matter
Yeah.
how many times you image it. It's great. Jamie, why not sent this one in? Hi, Chris. I took these photos of the waxing gibbous moon and the Pleiades Tuesday night, so we're going to show the Pleiades here in a second. She says, I used my binoculars. It's my first decent photo of stars. I don't mind playing around with my phone when it's 8 degrees outside, she says. Yeah, come on now. You're getting spoiled.
Look at that.
Look
One,
at
two,
that.
three, four, five, six, seven.
Awesome.
You pick
And
up 7 sisters real easy.
Now, the problem is, Jamie, is as the temperature comes up, so does the daylight. So we tend to lose on the other side as well. But we will get to a nice point here for sure soon. So, well done.
Oh, Kathy says the skunk is here waiting for me every night.
Well, there you go. Then you must want to have a look through your eyepiece.
I saw that Pepe Le View.
Pepe Le Pew. Wah, wah. All right. We got this one from Stefan Picard. I believe, yes, it is. Stefan, he says, slow week this week, but had time to work on stacking some captures from last week. Here's one from March the 20th. Awesome.
Oh, nice. Wow.
Very well done.
Love the detail.
Lots of
Oh,
detail.
yeah.
Yeah, just love that very long Terminator.
I just love looking at those shadows, eh?
Yeah.
That's incredible.
Then we got this one in from Jason
Jason.
Dane. Yes, Jason
Yeah.
Dane. Yes, it is.
Yeah.
Wow.
Yeah.
Nice shot. Yeah.
That's a fantastic shot.
Jason
Wow.
says this is a seven panel mosaic taken near Bayswater, Nova Scotia. It covers about 90 degrees of sky from Ofuchi. I know you can say it better. Ophiuchi. Yeah, Ophiuchi. There we go. Thank you. East. It's 12 by 10 second exposures at ISO 6400 f2.8 for sky at each stop, plus one 60-second foreground shot at ISO 1600. The stacked sky and foreground images were each stitched together to make a panel and then blended and edited in Photoshop. It was taken on March the 21st. Awesome. Awesome shot.
Look at the prancing
Yeah.
horse.
The prancing pony.
Wow.
Yeah.
Yeah, he's
Stand
got some nice dark skies down there.
What's that?
He's got some nice dark skies down
yeah,
there.
obviously. Look at that.
That's beautiful.
Incredible. Good stuff. Thanks, Jason. And we'll spring that one out. And he did send me one more. This one. He did the
Yes,
mosaic
sir.
of the heart, he said, this week as well. 2 14-hour panels with my Esprit 100.
Very nice.
Yeah, that turned out absolutely amazing. That photograph he's got online, and you can actually see a high resolution copy of that.
Okay.
You should go to a site and look at it. It's beautiful.
Oh, nice
Yeah.
job.
Yeah.
Well done. Well done. Lots of good astronomy shots this week. We get this one from Renat. Renat said, this is a perceptual space fog, or the whale nebula, she says. Doodling with liquid acrylics and inks on a gray sky day in March, Back Bay. Awesome. Thanks, Renat.
Yeah, I like it. Whale Nebula. That's cool.
Paintings you never get tired of her paintings. They're just so amazing.
Got to check her out at renatart.com. Awesome stuff. And if you'd like to send in your photos, we'd love to get them, as we do here. You can send them into Sunday Night Astronomy Show at gmail.com, or you can actually just send them to my Facebook page if you like, if that's easier for you. We love getting your photos. We love celebrating them, celebrating all your work out there. So congratulations, everybody. Great shots.
Well done.
Well
Beautiful.
done. And I'm going to go back out of this, and I'm going to go stop presenting.
So we can do Rosanna's segment next week because it's not timely. So
Okay. Okay, we
Yeah.
can do that. Yeah, because we're looking at about 9:10 right now. So we're probably going to, wow, that hour went by fast.
it doesn't take long.
Gosh, that goes by fast. This time goes by way fast. Okay, let's just check, make sure we don't have any questions before we sign off here. Yeah. Let's just make sure we get everybody's questions, because I do encourage people to offer questions. So I'm just going through YouTube here in a second. I think I saw one here from Paul Crowder had said, have you guys ever captured Nova Cassiopeia? Paul, have you ever captured
No.
that? No?
The
No.
Cassiopeia A, the big supernova.
Must be. There's another one up there, is there not right now? Wasn't there a new Nova? New
Yeah, there's some
supernova?
chatter about that. Yeah.
Yeah,
I
just,
didn't know much about it, but I was thinking of trying to go for Cassiopeia A, but for where my observatory sits right now, it's finally into the trees.
okay, yeah.
So you gotta wait till fall.
We'll have to wait till fall again. Okay. Okay, just looking down through. Oh, hi from Montreal, Quebec. Welcome.
Hello.
And welcome from New Jersey as well. Hey, got a great crowd
Wow.
in here. Okay, so we're going back over. I'm checking on Facebook here just for a second to be sure I get everybody's questions answered on this side. Sorry, folks, just bear with me. Just like to make sure that we don't leave anybody out there hanging. What's the best telescope to buy? Nelson, that's a great question. that is the $1 million question. The best telescope you're going to buy is going to be the one that you're going to take out the most often. That's
Watch last week's show.
Yeah.
Yeah, we do a whole show on that.
Yeah, and we have done a few shows on that. If you go back in our history a little bit on YouTube, you'll find a number of shows that we've talked about telescopes, binoculars, eyepieces. But the best telescope to buy is going to be the one that you take out the most often. That really is it. Like you can look at Mike's line up behind him there, and Paul's line up behind mine behind me. But you know, the one that probably the one I use the most often is this little guy right back here, because it's so easy to pick up, carry outside, take a quick look at the moon, bring it back inside, and plop it back down again. So the best telescope is going to be the one that is the most easy for you to set up. Because if it takes you a long time to set it up and you get frustrated about it, you're going to say, you know, I'm not going to bother with that tonight. And even if it's binoculars, there are two telescopes joined together. If those are portable and those are something that you're going to encourage you to get outside and take a quick look at the moon or a quick look at the horizon, the Milky Way, whatever, that's your best bet. There are lots and lots of talks about telescopes. We've done a number of them in the past. You can start anywhere from, say, $150 for something really low line to thousands of dollars. It all depends on what you plan on doing with it, how much time you plan on spending on it. I wouldn't suggest astrophotography to start off with. I would suggest basically learning the night sky first. I would even always suggest binoculars first before even a telescope. I think you guys probably agree with that, just to get out and learn where things are in the night sky first. Go to your local astronomy club. Find a local astronomy club. Find a star party event. Go talk to them. They'll help you get started. You can take a look at a public event. Well, they're hard to find right now, but normally at public events you can find lots of people with different telescopes who just love to talk about their equipment, and they will really help you get started. A lot of clubs loan out telescopes for free, like ours does, to borrow for a month at a time and bring them back. So if you get a chance to try them out first before you go make your big investment, and a telescope should be considered as a major investment, but it's something that you'll keep for your lifetime if you get the right one. And you can pass it on for other generations as well. And the sky is not going to change in our lifetime, so you don't have to worry about anything like that. I usually suggest a manual telescope to start with, because that helps you, force you to learn where things are in the night sky. So that's just my quick thoughts on it, but we could go into lots and lots more about it. But there's lots and lots of ideas of different opinions out there on what you consider for your first telescope. But I always suggest something small, portable, lightweight, easy to use, and don't spend a whole lot of dollars on your first telescope, because if it's something that you don't like doing, spending hours outside in the cold, in the night sky, you're not going to enjoy this hobby.
Don't buy one.
Don't buy one. You have to enjoy sitting in one spot or standing in one spot for hours at a time. And that's what it takes. But that's the passion. That's what develops with you. And all of a sudden you find out, like we are here, an hour and a half into our show. So hopefully that helps a little bit. Okay, so folks, let's sign that off then for tonight. So in closing tonight, our special thanks once again for all your continued support out there. We're going to thank Rosanna for her continued contribution to our show, as we always do. We're going to hopefully get to her topic again, but we will get to her topic again next week for sure. And we'd also like to express our thanks to all the great folks at Astronomy Plus for helping sponsoring our show. Remember, too, we do love getting your photos, so send them in to SundayNightAstronomyShow@gmail.com, and we'd be very happy to show them up here in our show first. And also, you can send them into my Facebook page, again, Astronomy by the Bay, and I collect them in the segment as well. So we're also looking for suggestions for topics for future shows. I do have a list of topics that we're going to get through over the next number of weeks that you have sent in. Thank you very much. So if you do have anything that you would like us to discuss on a future episode, please just send your request to the same address, SundayNightAstronomyShow@gmail.com, and we'll do our best to make it happen for you. We also ask that if you enjoyed the content here tonight and you joined us from YouTube, please consider giving us a like and subscribing to our channel. And please let your family and friends know as well that we are here at the same time every Sunday night to help entertain and educate you on the night sky. So for now then, from Mike, Paul, and I, and an absent Trudy, we'll have you back again for sure. Stay safe, everybody out there. We wish you all clear skies, and we hope to see you again here next week. And remember, as we like to say, guys, keep your scopes pointed up.
Pointed up.
Thanks, everyone. Have a great week. We'll see you again next week.
Cue the music.
Cue the music. Good night, everyone.